Good morning, friends. Welcome back to math. We are on lesson 8.8 today, and today's lesson is all about solid shapes, and it's going to be a little bit tricky because we are not together and I can't show you the solid shapes in person, and I can't hand you the pattern blocks that you would normally use for this lesson. But I think with the pictures that I have and with explanation, we will get through it. So you're just going to have to do a little imagining today. But let's go ahead and get started on our slate work. So on the piece of paper that you have, or hit pause and grab a piece of paper, go ahead and write down how many would this fraction of 6 be. If the whole group is 6, what is 1/6 of the group? It would be 1. So same thing, if the whole is 6, how many would 3/6 be? 3/6 of 6 would be 3. And if the whole group is 6, how many would 5/6 be? 5/6 would be 5 of the whole 6. All right, now imagine the whole group is 8, and same thing. How much would you have if you had 2/8 of 8? You would have 2. What about 0/8 of 8? How many would that be? 0. And what if you had all 8 of the eighths? You would have 8 of them. All right, this time we're going to switch it around a little bit. I'm going to tell you how many you have, and you're going to tell me what fraction of the whole. This time the whole group is 12. If you had 1 of all 12, what fraction would that be? That would be 1/12, or 1/12. What if you had 6 of the whole 12? What fraction would that be? That would be 6/12, or we could also call that 1/2. Those are equivalent fractions. And then finally, what fraction would you have if you had 12 out of all 12? What fraction would that be? That would be 12/12, or we could call it 1 whole. If you had 12 out of all 12, you would have the whole thing, or 1 whole. All right, when we look at this math message, it says, take a square pattern block, trace around the edges, compare the shape you drew to your pattern block. What do you notice? Well, you don't have a pattern block, I know, but maybe you have something square at your house. If you do, hit pause, run, grab it, and trace it. If you don't, do your very best to just freehand drawing a square on your paper. I've done that here. It's not perfect, but you can notice that this square has 4 sides. What else do you notice about a square? That's right. All sides are the same length. What else? Yeah, it has 4 angles, and they're all right angles. What else do you notice? Yeah, is this a 2D shape or a 3D shape? What do you think? Yes, this drawing is what we would call two-dimensional, or 2D. We say that it's only two-dimensional because it only has width and length. It doesn't take up any space. Now imagine if I handed you a square pattern block. A square pattern block in your hand, would that be two-dimensional or three-dimensional? It would be three-dimensional, or 3D. And the reason the pattern block would be 3D is because it has 3 dimensions. It has height, width, and length. It takes up space. Today we're going to explore 3D shapes, and the name that we have for them is prisms. We are going to call the 3D shapes prisms. Would you go ahead and open up your journals? We're going to look at journal page 272. I'll write that at the top. Hit pause if you need to and then come on back. But the top of page 272 says pattern block prisms. So the directions aren't really going to work for us, but you do see that there are 1, 2, 3, 4 prisms on the page, and they've created these prisms by stacking up pattern blocks. So if we were in class, I would have you stack up these pattern blocks to make these prisms, but since we're not, we're just going to observe what's on the page. Would you focus first on this prism? I'm wondering which shape pattern block they used to make this prism. Exactly. They used triangles and stacked them up to make this prism. Let me show you this on this page. This is the same thing. If you had stacked triangle pattern blocks up together, it would make this what we call triangular prism. I want you to notice some things about this triangular prism. The first thing is the shape of the side it's sitting on. What is the shape of the side it's sitting on? It's a triangle. Whatever shape the base of the prism is, in this case a triangle, that is what the prism's name is. So in this case, its base is a triangle, so it's a triangular prism. You will notice that also there are these sides that we call faces. Faces are the flat sides that are not the bases. The base is what it sits on. So in this case, what is the shape of the face for this triangular prism? It's a rectangle. But since the base is a triangle, we call it a triangular prism. How many faces are there on this triangular prism? There are 3. So you can see the one that the arrow is pointing to. The second face is this side. And then the third face could be hard to see, but it's the back side here. So there are 3 faces. Base is a triangle. The faces are rectangles. Let's look at the next shape. It is a rectangular prism. And the reason it's a rectangular prism is because the shape of the base, the side it's sitting on, is a rectangle. So we're going to call it a rectangular prism. It, of course, also has faces. How many faces does this rectangular prism have? It has 4 faces. So this one that the arrow is pointing to, the face that's opposite that, this is a face, and then opposite that is the 4th face. We've looked at the base being a rectangle, and then its opposite side is a base as well. And then you'll notice this word edge, and it's pointing to this line here. An edge is where bases or faces come together. They are straight lines where bases or faces come together. And then finally, we have this word vertices. Vertices are the points where the edges come together. So if you were holding this shape in your hand, these vertices would feel kind of pointy. I'm circling each of them, and you could maybe imagine that if you touched those vertices, they would feel a little bit pointy. So each prism has the side it's sitting on, which we call the base. It has other sides that it's not sitting on. We call those faces. It has lines where the faces and bases come together. We call those edges. And then it has these points where the edges meet, and we call those vertices. All right, let's look back at the journal page. We've talked about this first prism being a triangular prism. What do you suppose we would call this next prism? Remember, we're going to name it by the shape of its base. Yes, So you might call it a square prism because the shape does appear to be a square. Another thing that we could call it is a rectangular prism because we know that squares are also rectangles. And then how about this third prism? This third prism we might call a trapezoidal prism because of the shape of its base, but I want you to notice the sides and the edges and the vertices. And then finally, what do you guess we would call this? We would call it a hexagonal prism because the shape of its base, the side that it's sitting on, is a hexagon. So we would call it a hexagonal prism. All right, I'm going to change the directions a little bit on this page. Down here on the bottom part of this page, I don't want you to do what it's asking you to do. Instead, what I'd like you to do is describe what you notice about each of these prisms. And what I mean by that is tell me how many bases and what shape they are. Tell me how many faces there are, how many edges there are, and how many vertices there are for each of them. If you run out of space, you could write it on a separate sheet of paper, but I want you to do your best using the words bases, faces, edges, and vertices. It doesn't want to make an S. Vertices. Well, imagine an S at the end of that word. To describe each of these four prisms. What is the shape of the base? How many bases are there? What are the shapes of the faces? How many faces are there? How many edges does each prism have? And how many vertices does each prism have? After you do that, go ahead and move on to Math Boxes 8.8 and then later today, HomeLink 8.8. All right, thanks friends. I'll see you back here tomorrow.